Hello everyone, my name is Sid, and today we get to talk about something fun, cricket. I hope you all are enjoying the T20 Cricket World Cup games. I am, and for three reasons. One, I love cricket, like most of us do. Two, for the first time the T20 World Cup is being hosted in the US. And three, this past weekend, I got to try out AIP to build the best squad for the Indian cricket team. If you all haven't figured out already, I'm rooting for Team India, but you're free to essentially try out what I'm building in AIP for the team of your choice. So with that said, let's begin. The first application that I'm going to begin in is called AIP Logic. It's a tool for builders like you and I to create no-code functions that are composed of various blocks of logic. In this case, the first block that I'm going to put together is the use large language model block that will allow me to first curate a potential squad of players for the Indian cricket team. And I've pre-curated some of the prompts that I'm going to use for this example because I was trying this. The first prompt that I'm going to use is going to define the role of this LLM. In this case, I'm modeling it as the coach, and its incentive is to make Team India win the ICC World Cup 2024. The meta task there is to figure out what the potential squad would look like, and I want to give it some preconditions, which is it has to consider the location and the pitch of where the games are being played, and it must return exactly 16 players, so I can pare it down further. I'm not going to give it any tools. I will eventually, but not for now. The other thing is I could choose the return to be a data type of any of these types that you see, but I'm going to keep it at the primitive type string. The other thing is I could have also chosen the model of my choice. In this case, I'm leaving it to GPT-4, but I've also tried it with other large language models. So that said, let's run this block and see how it performs. While it's executing, I can see this debugger view, which is very GDB or JDB centric. My C, C++, and Java developers would know. The next thing it also does is it gives me a reasoning behind how it has gone about selecting those players. And finally, it gives me the results, which are the 16 players I asked off of it. On a cursory look at the 16 players, I can see that it is a good composition of batters and bowlers, and also some all-rounders. I can also see that there is a mix of young and senior folks, which is generally the composition that Team India rolls with. So it makes sense on a cursory look, but if I were to actually look at the reasoning, I see that it has considered location and pitch conditions that are pretty generic in nature. The other thing is that it is considering form and fitness of the players in their current state. But when I look at the players, I can see that some of them may not actually play the T20 format of the game anymore. So the reason for these two assumptions or hallucinations is that GPT-4 is trained only up until 2022. So if it had to give me an accurate result for something that's in 2024, I would either have to give it context or I would have to use another model that is trained up until 2024. So that said, I'm going to give it some context that I copied from Wikipedia, which essentially contains more information about the ICC T20 World Cup. And with that context provided, let's rerun and see if it's able to come up with a better result. I can see that it has considered the correct pitch conditions, this time of the West Indies and the US, who are the actual co-hosts of the tournament, and that it kept some factors the same, which is considering a mix of experienced and young folks, and also a good team composition of batters, bowlers, and all-rounders, which is exactly how Team India does it. The one consideration it has missed this time is the players who are playing the actual format of the game in 2024. And that's because it doesn't have the context of who's playing the T20 format today. So that's something that I can also provide to it as context. So players who are playing the T20 format of the game today. But as I'm writing this, I realize that the complexity of the prompt is getting a little too big here. So let me remove all of this jargon and use some of the tools that are at my disposal. So what I'm going to do is I'm going to call the query objects tool, which allows me to select the objects that I've pre-curated. So in this case, for example, the player object, which has properties such as who's the player, whether they're actively playing the T20 format of the game, and things like that. There's also information about the tournament, and there is information about the country, which essentially keeps properties such as the pitch conditions, average rainfall, and things like that, which are essential at coming to a decision. these objects within the ontology are backed by datasets that I uploaded, and these are notional in nature, but essentially they contain all of the fields that we need to get to a result that is going to give us the best squad for the Indian cricket team. So that said, let me rerun this and see how it performs. Cool. With that context provided, I can now see that it has actually looked up the tournament within the objects that I provided. And in those objects, it encapsulated information about the countries that are hosting this tournament. So it went and fetched the countries from the country object that I gave it. It figured out what the pitch conditions are in the US and the West Indies before making the decision on who among the 32 players would be selected in this squad of 16. And then finally, it has given me that squad as the potential squad that I could be using for the games that are hosted now. The minor modification that I'm going to do before moving forward in this process is I'm going to change the type of output from a string to a set of objects, because I don't want any of that peripheral information. I only care about the players who are going to play or who are going to be selected as the first potential squad. And what I'm going to do next is I'm going to use this potential squad to further optimize or curate the list. So now that we have that potential squad of 16 players, I want to further curate this list to an optimal list of 14 players based on health and performance metrics. What I'm going to do is I'm going to chain a LLM block onto the previous block, and I'm going to use the results of the previous block as input to this block. So I'm going to say potential squad, and I'm going to use the variable that we curated from the last block, and I'm going to give it an instruction to select 14 players based on health and performance data. The objective function here is the same, which is to make Team India win, role playing as the coach of the Indian men's cricket team. And I'm going to call this block something more meaningful. So let's call it the optimal 14. Awesome. Now I need to actually provide it access to the health and performances. Otherwise, it is prone to using the stale data that exists in the model itself. So what I'm going to do is I'm going to see if I actually have these objects. It looks like I have the health object. So I had uploaded some notional data about the player health. But I remember when I curated the ontology, I left the bowler performance and the batter performance as empty datasets. And I did that because I wanted to show you how I could connect a CSV with all of this information to the dataset, which is at this moment a shell of a schema. So in this case, I'm showing you those datasets. They're basically just the schema with the data types that it expects. I'm going to jump into Pipeline Builder, where these datasets were first curated. They were essentially manually defined. What I'm going to now do is I'm going to upload the CSVs that actually contain information about the health or about the performance of these players. Now that they're uploaded, let me just quickly review the shape of the data within these tables. While I was browsing through these datasets, I realized that the ones that I've uploaded and the ones that are backing the ontology are slightly different. As you can see, the names of the columns here are in lower snake case, whereas in the ones that were uploaded were title case. So I'm going to have to do that transformation. Additionally, the ones that are uploaded only capture the names of the players, but not the player IDs. So that's something that I'm also going to bring in. So I'm going to do some of those transformations live. So here, for example, I'm going to transform this table. I'm going to normalize the names of the columns from title case to lower snake case. I can see that preview. Let me also name this transformation. Another thing I can do here is I can use the exact same transformation to replicate those steps for the batter. So in this case, I'm merely going to rewire after copying the first transform. I'm going to change this name so it represents the right information here. And as you can see, it was able to essentially copy the same transform onto the batter dataset. Now, the other thing I needed to do was add the player ontology to account for the player ID, which we currently don't have access to. So let me get the player dataset. And what I'm going to do here is I'm going to join these transformations with the player ontology in order to get the player ID. I know that both datasets contain the name of the player, so I can join on that condition. And then finally, all I want to do is keep the player ID and all of the other columns. So that's done. Awesome. After a few more transformations, I can now select the uploaded batter performance dataset and back the batter performance dataset that is actually backing the ontology. And I can do the same thing for the bowler performances. And then I'm ready to run this pipeline. Cool. I've set off the build now for running these pipelines. Once they're complete, they should sync that information into the ontology, and we should see more than 0 objects populate here for the batter and the bowler performances. Awesome. Now that I see that these edits have finished indexing into the ontology, I have 16 batter performances data to actually pass through to my logic function, and the same applies to bowler performances as well. So what I'm going to do here is I'm going to query those specific objects. Firstly, the health of the player, second, the performance of the batters, and third, the performance of the bowlers. The other thing that is going to further optimize the way the ontology is traversed is passing information about the link between the bowler's performance and the player, because we're passing to this logic block a set of players. To traverse from those players to their performances, having a relational link helps. The same applies to the batter performance as well as the health of the players. And now it doesn't have to do an exhaustive search against all of the rows that exist within these 3 tables. It essentially is able to traverse the link that we've already configured and indexed into the ontology. What I expect as an output here is also a set of objects that represent the players themselves. And finally, instead of the potential squad being returned, I want the optimal 14 block to be returned, and that gets rid of the warning that this block was actually unused. To take a step back, what we've done here is we've created a superset of 16 players, and then we've chained that LLM block with another LLM block that uses it to further pare it down to an optimal list of 14 players based on a few different metrics such as health and performances. Now that said, let's run this and see how it performs. Awesome. Now that it has finished executing both these blocks, I can see that for the first block it used the same logic, which was essentially curate based on the pitch conditions and use the player, tournament and country ontologies to get that potential squad of 16 players. Then it passed the ball to the second LLM block where it was supposed to curate the optimal list of 14 players. Here again, it seemed to have made a few mistakes in how it was doing the traversals. When it figured it out, it found the health information of the first player. Then it also found the metrics or the performance of the first player. And then it repeated the exact same thing for a few different players before it arrived at the list of 14 players that we can now use. So this is not to say that this is the perfect list of 14 players that we can essentially use. But it's a start. It allowed us to essentially use the reasoning capabilities of the large language model and to automate the process of proposing what the squad could look like based on all of the metrics and information we thought were pertinent. Now that we've created these composable blocks of logic and chained them together to create this logic function, another thing I can start to do is parameterize some of the things that we're calling out here. For example, we're only doing this for Team India, and I promised you could reuse this workflow for the country of your choice. So let me follow through on it. Instead of saying the Indian men's cricket team explicitly, I can parameterize that into a variable called country name, which would be an input to the specific function, and then I can use that parameterized variable or that input to the function, and then it would essentially use that variable to make any kind of judgment calls. For example, if I open up the debugger view, it gives me the optionality now to specify the name of the country. In addition to this just being a primitive type, I could have also caused this to be an object. So in this case, if you remember, we had a country object that stored information are attributes about the country itself. So instead of passing in an explicit string, I could essentially do the name of the country deciphered or as a derived property of the base object called country. So in this case, this is how it would look like. And then we've got the ability to essentially run this with the parameterized block here. And here, for example, I can select all the countries that was available to me within the ontology. Awesome. Now that all of us know how to curate the best squad for the country of their choice, I wanted to have a little bit more fun. So what I wanted to do was upload audio clips about people evaluating these players on the field. These are all notional uploads. I essentially asked my friends Wes, Dom, and Alex to upload field evaluations about Rohit Sharma, Virat Kohli, and KL Rahul. If I play one of these clips back to you, I can then show you how I transcribed these audio clips into text.
Virat Kohli, the run machine, is showing his typical intensity during...
That's my friend talking about Virat Kohli. What I'm going to do is then use this in Pipeline Builder, and I'm going to transcribe it using the Whisper model. So what I'm going to do here is I pass this field observation media set as an input to a transformation that essentially does a conversion of audio to text, and it's using the Whisper model on the back end. The next thing that it does here is it tries to extract the name of the player, because to link any of these field observations to the players themselves, you need the name of the player. So I was able to use a large language model to extract the name of the cricket player who was being talked about. And after a few different transformations and joining with the player ontology, I got a table that essentially had the name of the player, the transcribed audio from the folks who recorded it, and then also the player IDs. And using these player IDs, I was then able to link the field observations with the players themselves. As a result of all of this, what I could do then is, in addition to passing the health, performance metrics, and player information, I could also pass field observations in curating the optimal 14. Now that we figured out how to create the optimal squad of our choice for the team that we're rooting for, using structured information sitting within CSVs and unstructured information that is sitting within audio clips, I want to now take a look at how I can use some of these functions in end-to-end operational applications. So after publishing this function, I was going to create an application in Workshop which allows me to consume the ontology and build end-to-end operational applications. I'm not going to build one from scratch here because I was already playing around with one before. In this case, I had tried curating a command center for a coach type of a person to come in and then filter the players that they wanted to look at, either by country or by the type of the player or by both. And what these essentially are widgets that are backed by the ontology. So if you can see, this Workshop application is merely backed by 4 types of objects. And if you look at the variables that are curated here, those are the ones that I'm actually using to back some of these widgets. So in this case, one of the variables was all of the cricket players filtered by that filter widget that we had set earlier. And once we change those, this variable changes and thus the information that is displayed to us. So this high fidelity application builder allowed me to curate this type of an application very quickly. Another interesting thing that I was trying was using or creating one of the interactive widgets. So in this case, I used the AIP interactive widget that allows me to create like a ChatGPT style place where I can ask questions about context that is stored within the ontology or that's selected in any one of the widgets on the screen. For example, here I was giving this widget context about the player that was selected, about field observations about them. So it was as simple as selecting the player, linking the field, finding the linked field observation, and so on. So by means of curating these objects and their linked objects within variables, I was able to back a high fidelity application where I could start to take some decisions. So if you were bowled over, or if I hit you for a 6, and I'm going to stop with the cricket idioms, I encourage you to try this out on the build with AIP links that we've provided. And I hope you all have a good innings.